Physics. Topic: Electrostatics. Electrostatics is the study of electric fields, charged matter and their characteristics. Electric charges are a fundamental property of matter that cause it to experience a force when placed in an electric field. Electric charge is also current multiplied by time if it flows through a circuit. The law of conservation of charge states that the charge can neither be created nor destroyed. It can only be transferred. Here in the example, the glass rod becomes positively charged, which means it has lost electrons. The silk cloth must have gained exactly the same number of electrons by the law of conservation of charge. Coulomb's law states that the force between 2-point charges Q1 and Q2 at a distance, r, apart in vacuum is given by force equals K into Q1 Q2 by r squared. The value of K is 1 by 4 pi epsilon 0. Let's do a simple problem. Calculate the electrostatic force between two charges of magnitudes 2 Coulomb and -1 Coulomb separated by a distance of 1 meter in air. Calculating the force using the formula K into Q1 into Q2 by r squared, we get force equals -18 into 10 raised to 9 Newton. Principle of superposition. If many charges are present, the total force on a given charge is equal to the vector sum of the individual forces exerted on it by all other charges taken one at a time. Electric field is a region in which a force would act on an electric charge. The strength of the electric field is given by the equation. Electric field strength is equal to force divided by charge. Electric field can be due to an isolated point charge, electric dipole, or a charged conducting rod. Electric field lines are imaginary lines used to visually represent the electric field in a region of space. Field lines originate from a positive charge and terminate on a negative charge. A sample problem to find electric field at a point 10 centimeters from a charge of 5 microcoulomb. Using the formula E equals kq by r squared for electric field, the answer comes to 4.5 into 10 raised to 6 Newton per coulomb. The field is directed away from the charge since the value is positive. The electric dipole consists of two equal and opposite charges separated by a small distance. If Q is charge, F is force and D is distance, dipole movement is defined as Q into D. In a uniform electric field, a dipole experiences a torque but no resultant force. The formula for torque is derived as dipole movement into E sine theta. A sample problem to find torque, using the value of dipole movement and the angle. The solution is found to be 1 milli-Newton-meter. Electric flux is the number of electric field lines passing through a surface. Formula for flux is EA cos theta, where E equals electric field, A equals area of surface, theta equals angle between field and normal to surface. A sample problem to find flux. Using the values given, the flux is calculated to 5 Newton-meter squared per coulomb. Gauss's law states that the electric flux through a closed surface in an electric field is equal to Q by epsilon 0, where Q is the net charge enclosed in the surface and epsilon 0 is the electrical permittivity of vacuum. Gauss' law is applied in the field of electromagnetism, fluid mechanics, gravitation, and even to simplify integrals in mathematics. Video by Anand Mohandas.